Thanks for joining me again. In our last few videos, we've built several key features for our client, Bluestone Industrial Components. All of this work has been done on a local development machine. While that works for a single developer, in a real-world project, a team of developers needs a centralized, automated way to bring everyone's code together, build it, and create a single, reliable, deployable package. This process is called continuous integration, or CI, and we will now build our CI pipeline. The process begins in Azure DevOps. After opening our project, we'll navigate to the bottom left corner and click on Project Settings. In the Settings menu, we'll look for the Pipeline section and click on Agent Pools. To create a new one, we'll click the Add Pool button. This opens a configuration pane where the most important choice is the pool type. We will select Self-Hosted. The reason we choose this is that a Dynamics 365 build requires a specific set of SDKs and compilation tools that are not available on the standard Microsoft Managed Agents. By creating a self-hosted pool, we are telling Azure DevOps that we will provide our own specialized build machine, the one we'll create later in Lifecycle Services, which has all the correct tools installed. Next, we'll give our new pool a descriptive name. We'll leave the grant access permission to all pipelines option checked and then click Create. We now have an agent pool ready for our dedicated build machine to join. Next, we need to provision the specialized build virtual machine that will act as our self-hosted agent. We'll deploy this directly from Lifecycle Services. Inside our LCS project, we'll start by clicking the main menu icon and selecting Cloud-Hosted Environments. On this page, we see a list of our existing environments. To create the new build server, we'll click the Add button. The first step is to select the application and platform version. Here, I will select the 43 version because the local development VHT that we have installed is of that version. This ensures consistency and prevents potential issues from code being developed on one version but built on another. Next, under Environment Topology, we'll select Dev Test. This presents us with several templates for different purposes. Since our goal is to create a machine specifically for compiling and packaging our code, we will choose the Finance and Operations, Build and Test option. This topology is essential because it comes preloaded with all the specific tools and scripts needed to run the automated build pipelines. Finally, we'll give our new VM a clear name, such as BIC build. Before deploying, we need to configure the link between this new machine and our Azure DevOps project. We will start by clicking the Advanced Settings button. This expands several configuration sections. The most important one for us is Visual Studio Team Services. Here, we must enter the exact name of the build agent pool we created earlier in Azure DevOps. This is the crucial step that connects this VM to our pipeline. Next, we need to specify a branch name. For those new to source control, a branch is essentially a separate copy of the codebase. It allows developers to work on new features in isolation without affecting the main, stable version of the code. By specifying the dev branch here, we're telling the build machine which copy of the code to initially sync with. We can also go into the Customize Virtual Machine Name section to confirm the name our server will have in Azure. Finally, we select the virtual machine size. We're choosing a size like E4v3. The E-series VMs in Azure are memory optimized, which is essential because the D365 build process is very demanding on RAM. This size provides a good balance between the performance needed to complete a build in a reasonable amount of time and the cost of running the server. With our settings confirmed, we'll agree to the terms and click Deploy. After we click Deploy in LCS, the environment status will first appear as queued, and then after a few minutes, it will switch to deploying. This process can take a few hours, and once it's finished, the status will finally change to deployed. With the machine ready, we'll head to the Azure portal. Under All Resources, we will find our new virtual machine, BIC Build 1. The very first thing we must do is set the administrator password. In the VMs menu, we'll scroll down to the Help section and click Reset Password. We'll enter and confirm a new password for the administrator account and click Update. Once the password reset is complete, we'll go back to the VM's overview page. At the top, we'll click the Connect dropdown and select Connect via Bastion. In the pane that opens, we'll enter the administrator username and the new password we just created, then click Connect. A remote session will now open in a new browser tab. Looking at the File Explorer on our new build machine, we can see it's a specialized environment. LCS has pre-configured multiple drives for specific database functions such as temporary storage and dedicated drives for SQL data and logs. If we navigate into the C drive, we can see folders like Dynamics SDK and Packages. These contain the core developer tools and source code directories that the build agent will use during the automated compilation process. This confirms our purpose-built machine is now ready. Now that the build VM deployment is complete, we can return to our Azure DevOps project to see the results. The LCS process has automatically configured our source control repository and build pipeline. To see what it did, we'll navigate to the repo section. First, by looking at the change sets, we can see a history of several automated check-ins. These were performed by the LCS deployment service as it initialized the repository. Next, switching to the files view, we can see the folder structure that was created. There is a trunk folder, and inside it, a dev branch has been created. This is the specific branch we designated during the VM setup. Inside this dev branch is a crucial metadata folder, which is the standard location where all our custom D365 source code will live. In addition to setting up the repository, the deployment also created a new fully functional build pipeline for us, which we can find under the pipeline section. While the pipeline created by LCS is functional, we still need to enable its automatic trigger. To change its settings, we'll click the Edit button in the top right corner. This takes us into the pipeline's definition, where we will select the Triggers tab. Under the Continuous Integration section, we will check the box to enable continuous integration. Now, we only want the build to run when actual source code changes. To configure this, we'll use the path filters. We will expand and select the metadata folder in dev branch and click OK. This ensures that the pipeline will only trigger automatically when a developer checks in X++ code and will ignore changes to other files. After saving these changes, our CI pipeline is now fully automated. Before we connect Visual Studio, we need to establish our primary branch. The LCS process automatically created a dev branch, but our strategy is to use a branch named main as the stable, central copy of our code. So, for this initial setup, we'll simply rename the auto-created dev branch to main. We can do this directly in the Azure DevOps web interface by selecting Rename, typing the new name, and then checking in the change. Later, we will create a proper dev branch from this main branch to use for our daily development. With the pipeline ready, we now need to connect our local Visual Studio project to this central repository. We'll start by opening the Team Explorer window, which we can access from the View menu at the top. In Team Explorer, we'll click the green plug icon to manage connections, then select Connect to a project. A dialog will appear, listing all the Azure DevOps projects accessible to our account. We'll find and select our specific project, BIC D365 Implementation, and click Connect. Now that we're connected to the project, the next critical step is to map a workspace. This creates a direct link between a folder in the online repository and a folder on our local computer. To configure this, we can navigate to File, then Source Control, Advanced, and select Workspaces. If a workspace already exists, we can select it and click Edit. Otherwise, we would add a new one. Inside the configuration, we set the source control folder to point to the metadata folder within our trunk main branch. Then, we map it to a corresponding local folder on our machine. This ensures that any code we place in this local folder is tracked by our central repository. Once the workspace is mapped, we need to add our existing model's source code to it. Currently, all the files for our BIC customer management model reside in the standard packages local directory on our local machine. Because our source control folder is in a separate location, we must manually copy our model into it. This is critical because it contains not just our X++ code, but also the model's descriptor and other files that the build server needs to compile everything correctly. Back in Visual Studio, Team Explorer will now show these new files under Excluded Changes. To include them, we'll click the link to review the detected files, which opens a Promote Candidate Changes dialog. We will confirm our files are listed and click Promote. Now the files appear under Included Changes. There's one final adjustment for our build pipeline. The pipeline uses a specific project file named axmodulesbuild to determine which models to compile, and it often expects this file to be in the root of the branch. To ensure our model is included, we'll download this file from the projects folder in the repository and copy it into the root of our local mapped folder. After that, we can simply promote this file and then finally check in all the files with a proper comment. After checking in, we can see the result in Azure DevOps. Our custom model now resides under the metadata folder, and the build project file is in the root of the main branch, where the pipeline needs it. The code we just checked in was committed to the main branch, which we'll treat as our stable protected copy. For our daily work, we'll now create a separate dev branch from main. We can do this directly from the Source Control Explorer in Visual Studio. Now, close this window. Just click the refresh icon to load the project. After that, just expand it so you can see the main branch. We'll right-click our main folder, go to Branching and Merging, and select Branch. In the window that opens, the source is already filled in. We just need to specify the target path for our new branch, which will be inside the trunk folder and named Dev. After we click OK, Visual Studio immediately prompts us to map this new server folder to a local folder. This is required to sync the new branch's files to our machine. We will create a corresponding new dev folder locally, paste the path in the map window, and then click Map. This process creates the new branch in the Azure DevOps repository and also downloads a complete copy of the source code into our new local folder. Finally, we can write a comment and check in all the changes to the dev branch. Returning to the pipelines in Azure DevOps, we can see that our recent check-ins have already triggered the build process. This is our continuous integration working as expected. If we click on a running build and examine the agent job, we can see a detailed log of all the steps it's performing. Let's walk through the key stages. It begins with initialize job and checkout, where the agent prepares the environment and downloads the latest version of our source code from the branch. The prepare for build step is specific to D365, where it stops services and gets the build tools ready. The main event is build a solution, which is where the X++ compiler is invoked to compile all our models. After a successful build, it performs a database sync, just like we do in Visual Studio, to update the database schema. Finally, it runs generate packages to create the final deployable package and publish artifact, which uploads that package back to Azure DevOps so it can be used in a release. To observe how this process works directly, we can look under the hood. Back in Azure DevOps, we can go to our pipeline and click Edit. Under the Tasks tab, we can see the exact sequence of jobs the agent performs. Each step, like prepare for build, is a specific task. If we click on it, we can see it's a PowerShell task configured to run a script named prepare for build. If we navigate back to the Dynamics SDK folder in the C drive of the build VM, we can find the prepare for build script being executed as a task. Similarly, build a solution task uses MS Build, a standard Microsoft tool for compiling applications. The Azure DevOps pipeline is simply an orchestrator. It tells the agent on our build machine which task to run, and the agent then executes these corresponding scripts from the SDK folder to do the actual work. This combination of the pipeline's instructions and the tools on the server is what creates our fully automated build process. After the build process is finished, which can take some time, we can click on the completed run to view its summary page. Here, in the related section, we'll see a link indicating that artifacts have been published. Clicking this takes us to the artifacts view. Inside the packages folder is the final output of our entire process, the software deployable package. This is the same type of zip file we previously created manually. This package is now ready to be uploaded to the LCS asset library and deployed to any D365 environment, following the standard update process. You can refer to the previous videos for the exact steps. With that, our automated process is now in place. In this session, we configured an agent pool, provisioned and linked a dedicated build VM, established a source control strategy, and created a pipeline that automatically builds our code on every check-in. Thanks for joining me again.